in this binary sequence, some number are binary number are missing. So which binary number are missing in this sequence? So here 0, 1, after then 2 is missing, 3, 4, 5 is missing, 6 and 7. So two number are missing, 2 and 5. So this is a unused missing number, this is unused state number. So this is called unused sequence number, otherwise called the state number. Now step 1, how to draw the diagram, state diagrams. So in the state diagram we will draw. So according to sequence 0, 1, 3, 7, 6, 4. This one is 0. After then 1. After then 3. After then 7, 6 and 4. This one the sequence. This is called the 0. The next state of 0 is 1. This is called the 1. Next state of 1 is 3. This one is 3. Next state of 3 is 7. This is called the 7. Next state of 7 is 6. Next state 6 of 4. And next state of 4 is 0. Now this is called the binary sequence which is given in our example. Now this is called the state number. This is called the state 0, state 1, state 3, 7, 6, 4. This is called the, also we define the state number. And 2 and 5, this is called the unused state. So we define 2 and here we define 5. Both are unused state. So unused state is defined outside of this counter. So this is the state diagram of synchronous state machine counter, but given the binary sequence. Now this state diagram, how to define the circuits for these state diagrams. So how many, so we define here in this example, we define here the design the clock synchronous state machine using the T flip-flop. We define here we need the T flip-flops. So how many T flip-flop we required in these state diagrams? So number of T flip-flop is required. The maximum count is 7 because here sequence number is given, maximum sequence number is 7. So 0 to 7, 0 to 7, that means 8 counting counter counting the 8 state. So for the 8 state, 2 raised to 3 is equal to 2 raised to 3 is equal to 8. So 3 T flip-flop is required. 3 T flip-flop is required for these state diagrams. After that, step 3, define the excitation table of T flip-flops. What is the excitation table of the T flip-flop? So in previous video we defined how to make the excitation table of the T flip-flop. So here we saw if present state is 0, next state is 0, so T flip-flop is 0. Present state is 0, next state is 1, so T flip-flop input is 1. And present state is 1, next state is 0, so T flip-flop also 1. And present state is 1, next state is also 1, T is equal to 0. The T flip-flop, this T flip-flop is made by the JK flip-flop. T flip-flop is made by the JK flip-flop. In the JK flip-flop, if J and K is 0, so output is unchanged, no change. 0 1 that means reset, 1 0 that means set, and 1 1 that means toggle conditions. This is called the T flip-flop is made by the JK flip-flop. So according to the JK flip-flop truth tables, we define the T flip-flops excitation tables. In the excitation tables 0 1 1 0. Another we say by using this excitation table of T flip-flop, here we will see the both the input are same. Both the input are same, the output is 0. Output is 0. Both the input are same, output is 0. And both the input are individual, that means different. Both the input are different, then output is also same. So these truth tables, this table is also called the XOR table, XOR gate table. So T flip-flop is also gate. So T flip-flop, in the T flip-flop excitation table we define Also XOR gate. In the XOR gate, if the input are same, so output is 0. Input are different, so output is 1. Now step 3, after the step 3, we define the excitation tables. We define the excitation table according to our excitation table T flip-flops. In the excitation table, we define the here total 8 state 0 to 7. So 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 and 1 1 1. So total 8 state is available. This is called the present state. So what is the next state? How to define the next state of all this state? For example, this state 0. State 0 is present state is 0, present input is 0 0 0. So what is the next input is this 0 0 0. So this next state, this next input is defined according to our state diagram. So we will see the state diagram. Present state is 0. So what is the next state for after the 0? So next state after the 0 is 1. Next state after the 0 is 1. So we will see here present state is 0. So what is the next state? Next state is 1. So 1 is this means binary number is 0 0 1. That's called the 1. After that 1. 1 next state is 3. What is the next state of 1? What is the next state of 1? Next state of 1 is 3. So here 1 0 0 1. So next state of 3 is 3. 3 means 0 1 1. After that 2. But 2 is a unused state. Here we define 2 is unused state. So we define here don't care. So define is 2, but 2 is directly connected with 0. 2 is next state. What is the next state of 2? What is the next state of 2? Next state of 2 is 0. So next state 2 is 0. So 0 0 0 0. After then state number 3. In the state number 3, next state of state number 3 is 7. So 3 next state number is 7. 7 that means binary number 1 1 1. After then state 4. What is the next state of 4? This is called the state 4. What is the next state of 4? Next state of 4 is 0. So here next state is 0. So 0 0 0. After then state 5. State 5 is also the unused state. So state 5 is also your unused state. So next state of 5 is also 0. So here also 0 0 0 0. Now state 6 1 1 0. What is the next state of 6? This is called state 6. Next state of 6 is 4. So next state is 4. So 4 is 1 0 0. Now state 7. Now next 7. This was state 7. What is the next state of 7? Next state of 7 is 6. So here next state of 7 is 6 1 1 0. So according to our state diagram, we define the next state of all the present state. Now how to define the T flip-flop outputs? This T flip-flop output is defined according our the excitation table of T flip-flops. According our the excitation table of T flip-flop. In the excitation table is this 0. If present state is 0, next state is 0, so also 0. If present, first of all see for the TC. First of all we see the DC. Present state is 0. Next state is also 0. Present state is 0. Next state is 0. So what is the output of T flip-flop? So we will see here. Present state is 0. Next state is also 0. The output is T is 0. So output is T is 0. As it is, present state is 0 for TC. According to this B, present state is 0. Next state is also 0. So present state is 0. Next state is also. What is our input of T? Input of T is 0. In the A present state is 0. Next state is 1. Present state is 0. Next state is 1. So what is the output of T flip-flop? Output of T flip-flop is 0. So here will mix it. Here output is 1. because here present state is 0, next state is 1. Present state is 0, next state is 1. So output is 1, output is 1. As it is, present state is 0, next state is 0. So output according to our two tables, our excitation, present state is 0, next state is 0. So input is 0, present state is 0, next state is 0, input is 0. Present state is 0, 1, so output is 1. Present state is 1, next state is also 1. Present state is 1, next state is also 1, so output is 0. Present state is 1, next state is 1, so output is 0. According to the T flip-flop excitation table, according to T flip-flop excitation table, we define all the T flip-flop excitation output. Now, after preparing these excitation tables, we define the K-map because we want to make the synchronous counter circuit. So we define the K-maps. So first K-map, here we prepare the K-map, we make the K-map for TC, TB and TA. So K-map for TC, K-map for TB and K-map for TC. Sorry, TA. So K-map for TC, here is called the TC. So whenever the 0 0 0, how to make the put the values of this K-map for TC? 0 0 0 state, 0 0 0 state. So what is the output of TC? 0. 0 0 0 output of TC is 0. 0 0 1, 0 0 1 output of TC is 0. So here also 0. 0 1 1, 0 1 1 output of TC is 1. So here output is 1. So here output is 1. 0 1 0, 0 1 0. What is the output of TC? 0. The output is also 0. So according to this, we put the values of all the 8 blocks. For the TB, 0 0 0, 0 0 0, 0 0 0, TB is 0. So here put the value is 0. 0 0 1, 0 0 1, value of TB is 1. So output is value is 1. 0 1 1, 0 1 1, output is 0 1 1, output is 0. Output is also here 0. And 0 1 0, 0 0 1 0, output is B is 1. So here also 1. So according to this, fill up all the blocks for TB, and according to this, fill up all the blocks TC. Now making the groups in the K-maps. So here one group is made, another one is individual. Here making the one groups and individual. What is the equation of G1 and G2? What is the equation of group 1? What is the equation of group 2? So we have defined the equation of G2 is 1 1 1 1, that means B A, and after then C, that's called the C bar. So G2 is equal to B A C bar. Here in this group we see upper side, in both the value 0 is common. 0 is in the both the value, 0 is common. So 0 this means B bar, 0 this means B bar, and here 1 that means C. So B bar C. So G1 is equal to B bar C. G1 is equal to B bar C. 0 common, so B bar, and 1, that's called the C. Now what is the value of the G2? Here BA, that means B bar A, this is called the B bar A, and this is called C, that's called the C bar. So G2 is equal to B bar A C. What is the equation of the G1? What is the equation? So we see the upper side only for B and A bar, but here left hand side no one is common. So equation of G1 is B A bar. Now for a TC, for T of A, which one make up the group? This one is group. What is the equation of this? So equation of this group is, here 1 is common, 1 is common here, so A, and this one is C, this one is, this is called the C bar, this is called the C, so A, C, so equation of G1 is C, A. So 3 equation we make it. After then, how to make the circuit by using these equations? First of all, write down the equations. First of all, write down the equation for TC. For TC, what is the equation of the TC? Equation of the TC is, this is called the G1, so B bar C plus equation of G2. Equation of G2 is BA-C bar. So BA-C bar. What is the equation of TB? So TB having the two groups, BA bar C and BA bar. B bar AC, sorry, and BA bar. So what is the equation of the T of A? Equation of the T of A is only for AC. Now using this equation we make the circuit of the for synchronous counter circuit. So in this circuit we need 3 blocks. First one is IFL. After then we need memory. After then we need OFL. Here IFL means input forming logic, memory input forming logic, that's mean we use some gate, memory we use flip-flop. In this example we require the flip-flop T flip-flop, and output forming logic, that's mean some gate output. So this is the block diagram of synchronous counter circuit design. According to this block diagram we define the circuits by using these equations. So for first of all we define the memory. So here required the 3 flip-flops. Here required the 3 flip-flops, 3 T flip-flops. This one, flip-flop 1, and flip-flop. We define the clock. This is called the synchronous circuit. That's why clock is given the simultaneously. So this is called the clock. This is called the T flip-flop, T of A. This is called the T of B, and this one is T of C. Output Q of A, Q of B, and Q of C. This is called the output. This is called the output. After then we T of A. What is the equation of the T of A? Equation of T of A means AC. So we just give the one AND gate and give the input. This one A, this one is C. After then, what is the equation of the TA? B bar AC plus BA bar. So we make the one gates. Equation B bar AC, this one A. Then we given the B here. B, this is called the A, this is called the B, and C. C also. This one is B bar A, C. I've done plus B A bar. Another gate is B A bar. So this one is B. We getting one inverter, and A bar. This one A. We given the one inverter. This one A bar. After then we add this by OR gate, and we getting the input for T of B. What is the equation of the T of C? B bar C, B A C bar. So first of all equation is B bar C, and another equation B A C bar. B A C bar. We connect with OR gate and we given the input. Connect the OR gate, we given the input. So B bar C, this one is B bar. It's called the B bar. After then we connect the C. This one is C. B A C bar. This one is B. This is called the A. This is called the A, and this one is C bar. B, C, this is called the C bar. So B, A, C bar connect with OR gate. Let's call this. So this one is called IFL. This one is called memory, and this one is called output section is, this one is called the OFL. So this is the synchronous counter circuits by using the T flip-flops. So thank you so much for watching this video. Thank you.